Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Staying warm might come at a cost, at least for the immune system. A study recently published in Cell Metabolism suggests that when mice are exposed to cold temperatures, their bodies may reroute energy reserves away from immune function to prioritize keeping warm. The study authors from the University of Geneva reported that the cold triggers changes in immune C. Cold exposure may tame excess immune activity in autoimmune conditions such as multiple sclerosis. We thought that an underexplored area in this theory is whether these maintenance programs will be able to compete between themselves for the energetic allocation depending on their survival values, Tchaikovsky said. In particular, defending the body against an onslaught of pathogens and infections is no easy task, and generating billions of cells for this purpose is very energy-intensive. When energy is scarce, the body has to make choices, and previous studies of caloric restriction that tamped down autoimmunity suggested that fueling the immune system might not be the priority. 2. We developed a general principle that we hoped could also be applied in the context of autoimmunity. In collaboration with co-senior author Doron Merkler, who studies immunity in the central nervous system, Tchaikovsky focused on multiple sclerosis, MS. This nerve-damaging condition is thought to be caused by rogue immune cells turning on their own body. Using mouse models, the researchers turned down the temperature to around 50 degrees Fahrenheit, which is not cold enough to put the mice at risk for hypothermia, but chilly nonetheless. Compared to the immune cells in mice kept at room temperature, cells from the colder mice had distinct differences in the molecules they produced. Cold-exposed, CE, mice with EAE had less damage to the nerves in their spinal cord, shown in purple. The phenotype is really dramatic, Tchaikovsky said. While mice with EAE had hind limb paralysis that kept them from walking normally, with cold exposure, the paralysis nearly disappeared. Even 2 days of cold exposure was enough to improve EAE symptoms. Spending time in higher temperatures, around 93 degrees Fahrenheit, seemed to have the opposite effect. By looking at other immune cells, the researchers determined that cold-induced changes in monocytes affected their ability to interact with and instruct T cells to attack the body's own nervous system. Although these findings are still far from being translated to humans, Tchaikovsky sees parallels. The improvement of living conditions in Western countries has gone in hand with the increase in autoimmune diseases, he said. With future studies, Tchaikovsky hopes to better understand how exactly the cold changes monocytes. He also thinks that this energy-based perspective on immunity could lend insights into normal immune function. Even in mice without EAE, his team found changes in monocytes. This might be why we are more prone to infections during acute cold, he said. References M. Spiljar et al. Cold exposure protects from neuroinflammation through immunologic reprogramming. Cell Metab, 33, 11, 2231–46. E8, 2021. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.